Indeed, Einstein reasoned that the missing term means that there is some process that we are ignoring. So we can look at it. How did this exponential come in the way? It came from the way that we isolated the intensity in this expression. The exponential came from the n2 over n1 factor in this expression when we isolated the intensity. So to have a minus 1 term in the denominator, seems that there is a term that is missing. That was Einstein conjecture. So Einstein essentially reversed the engineering what this term would be from the Planck function. So you write this in terms of ni times b minus c, that's the extra term times the intensity, is equal to n2 times a, where c is some multiple of the probability of occurrence of this process. Now, if you have this term, then you could write the intensity being equal to n2 times a over n1 times b minus c. So you have the negative term in the intensity that will give you the minus 1. Now, the fact that this probability c is negative shows that physically this term is in the wrong side of the equation. It should actually be on the right-hand side. In fact, the equation then should be n1 times b is equal to n2 times a plus c times I. So if this is absorption and this is emission, it seems that this is an emission process. It's a strange emission though, because it depends on the intensity. But let's go back to the equation for the intensity and then find the exponential. If we get to this equation in here and divide both the numerator and denominator by n2, then we have I is equal to a over n1 over n2 times b minus c over n2. Now, if again you substitute Boltzmann relation for the n1 over the n2, then the intensity becomes, to make a term minus 1 appear in the denominator, we divide and multiply the denominator now by c over n2. So if we could remove the factors of n2 that are following c, then we would have the functional form of the Planckian. So let's do that. Let's substitute c is equal to d times n2, where we just define a d. So the intensity then in terms of d is a over d over b over d, g1, g2, exponential of h nu over kt minus 1. Now this has a form of the Planckian. If a over d is equal to 2h ni cubed over c squared, and b over d is equal to g2 over g1. So with this equation here, indeed we find an intensity field that is consistent with the Planckian. The mathematical form is the same as a Planckian, and the coefficients that you find can obey this relation. As it turns out, this is the principle of the laser. This extra term here is stimulated emission. Let's see what it means. Let's understand what setting c equal to dn2 means. We can write the equation for the emission equal to absorption in terms of d. The process that is missing then is given by this. So d is the probability of this process happening. What is important here is that this process is proportional to n2 and to the intensity field. Now, because this is proportional to the intensity, it looks like it is an absorption process. However, it is also proportional to the number of atoms that are in the level 2. Since we assumed only 2 levels, and the level 2 is the most energetic, this process cannot be absorption. You had an electron here at the N2. There is a photon in the radiation field. Because the level 2 and the level 1 are the only levels that exist, this is a process that is making the electron transition from the level 2 to the N1. So it is an emission process. But it is an emission process that is somehow dependent on the radiation field. This term seems to tell us that the presence of a photon in the radiation field of exactly the same frequency as the transition from 2 to 1 will somehow lead to emission of a photon. Einstein called it stimulated emission. So a photon in the radiation field, if captured by an electron that is on the N1 level, will lead to a radiative absorption that happens with a probability B. Yet, for an electron at the n equal 2 level, the same photon may lead to stimulated emission, which is a D excitation, and this happens with a probability D. To keep the number of symbols to a minimum, let's keep the symbol B for transitions that depend on the radiation field, but give them subscripts indicating the jump that occurred. So what we call B so far, let's flip to mean B1, 2, because it means that the electron was at the level 1 and transitioned to the level 2. And D, then let's call it B21, because it means that the electron was at the level 2 and transitioned to the level 1. And just keep consistency with the A, even though there is only one spontaneous emission. Let's also call it 2-1, since it was also at the level 2 and then into level 1. Before, we only call it emission, but let's now call this process spontaneous emission, since we have now another process, which is stimulated emission. In terms of these terms, then the equation of balance becomes N1 B12 times the intensity is equal to N2 A21 plus N2 B21 I. And now then the coefficients are A2 over B1 is equal to 2h in e cube over c squared, and B12 over B21 is equal to G2 over G1. These two equations are called the Einstein relations. If these relations are obeyed, then the radiation field in this system of two levels reproduces the Planckian for all temperature. Notice that the fact that mathematically one can simply put the simulated emission on the left-hand side of this equation. That means that the process can also be thought of as negative absorption. Due to the interaction between the radiation field and matter, a photon was added to the field with the same frequency that would normally be absorbed. Now, remember that the intensity also encodes the direction. That means that the photon that is added is in the same direction as the incoming photon. The photon was essentially cloned, and is now intensifying the radiation field. In fact, modern technology uses this process every day in the form of light amplification by simulated emission of radiation, or the laser.